Hey everyone, welcome back to my channel. This is Rahul, and today we are tackling a super important problem for MAANG level interviews minimum jumps to reach the end. This question isn't just about coding, it's about thinking logically, handling edge cases, and efficiently solving problems under pressure. That's why it's a favorite among top tier tech companies. In this video, I will explain the greedy approach we will use to solve it and go through the code line by line and share some interview tips to help you ace this question. So make sure you stay till the end. So why this question is important? Now, before we dive in, let me explain why this is important. First of all, it tests problem solving skill. You need to find an optimal way to reach the end of the array, avoiding brute force solutions. Second, it focuses on edge case handling. Arrays with zeros or minimal input size can throw you off if you don't think critically. Third, it uses the greedy algorithm. This approach ensures efficiency, making your solution scalable for larger inputs, a must have skill for any backend or system design role. Alright, let's dive into the code and understand the solution step by step. So you can see based upon the element, if you are on index 1, you can jump one step. If you in the second index, it is 3, so you can jump 3 steps. As you can see, it's 9, so you can jump till end. That's why it getting output 3. So we have to find the minimum number of jump needed to move from first position in the array to the last position. And same like we have to return -1 if you can't reach the end of the array. So let's start. Here we have our method min jumps, and it we taking one input array and returns the minimum number of jumps needed to reach the end. So first of all we have to get the array length. At the initial stage we have to check two conditions. First, if the array has only one element. Okay, so if it is only one element, then we don't need to jump to any other because we are already at the end. So return 0. Simple, right? Next, if the first element is 0, then we are stuck and we can't proceed. So we return -1. So these are the initial conditions. Next, we need to initialize variables for tracking the jumps and ranges. First, I will initialize jump. So here jump keep track of how many jumps we have made. We start with 1 because the first jump is implied. Next, farthest. It tracks the maximum index we can reach at any point. So we will start at first. Next, current end. It is the boundary of the current jump range. When we reach this, we know we need another jump. So we will give it as array of 0. Okay. Now we will start our loop. We will use for loop. We will start from 1, I less than n, and increment I. So, starting from the second element, we look through the array to evaluate our gem strategy. First, we have to check if we have reached the last index. So, if I equal to n minus 1, then simply return gems. Okay, so here we just return the number of gems because we already reached the last. Next, we have to update the farthest point we can reach. We will use the math method. Farthest I plus array of I. Here, for each index I, we will calculate the maximum index we can reach by adding I plus array of I. This ensures that we always know the farthest point we can jump to. Next, we have to handle the end of the current jump range. If I equal to current end, um, when we reach the end of the current jump range, that's the current end, we increment the gems counter because we are starting a new jump, right? So gems plus plus. Next, if farthest is less than or equal to I, it means we are stuck and we can't proceed further. So we return minus 1. Farthest less than or equal to I. Return minus 1. Or else we need to update current end to the farthest point, extending our jumping range. So our section is done. At last, we have to return minus 1 if we exit the loop without reaching the end. Actually, this is a safeguard to ensure that if the last index isn't reachable. That's why we return minus 1. Let's run it. Yeah, it's running. So just recap the approach we used. First, greedy strategy. At each step, we calculate the farthest index we can reach, ensuring we optimize our jump. Second, edge case handling. Arrays with zeros or minimal length are handled upfront to avoid runtime errors. Third, efficiency. This solution runs in big of n time complexity because we traverse the array just once, making it ideal for large inputs. Submit it. Yeah, it's done. Zero point 0.6 second. Now, before we wrap up, here are some tips to ace this problem in interviews. First, understand the greedy approach. Don't overcomplicate the problem. Focus on how to optimize your range at each step. Second, practice each edge cases. Interviewers love to throw edge case at you, so be prepared for arrays like big of 0, 1, 0, 0, or 2, 3, 0, 1, 4. Like that, you have to prepare. Third, explain your thought process. In interviews, always explain why you are choosing a particular approach. For this problem, emphasize efficiency and scalability. Lastly, dry run the code. Before coding, simulate the problem with a few test cases to ensure your logic is solid. And that's a wrap. This question is a perfect example of how to apply greedy algorithms to real world problems, and mastering it will give you a strong edge in interviews. If you enjoyed this explanation, please give it a thumbs up, share it with your friends, and don't forget to subscribe to my channel for more such coding tutorials and interview tips. Until next time, keep coding and keep growing. This is Dowell signing off.